Hello, welcome. I'd like to spend a little time today talking to you a little about what Zephyr is doing to become ready for going after safety certification. My name is Kate Stewart, and I'm VP of Dependable Embedded Systems here at the Linux Foundation, and looking at how we can get systems to be dependable, which means safe, secure, reliable, etc., are very important in the embedded space. And so what I'd like to sort of do is talk to you a little bit about some of the applications that are starting to emerge. Obviously, I live here in Texas, in Austin, and was impacted by the event in February. No power to the house for a week. And when that sort of happens and the temperatures are cold, it really does almost become a safety issue, that things are up there and reliable and so forth. And I think there are many causes for why we were having issues, but time proved it was mostly the lack of winterization rather than anything else. And in Texas, obviously, there's a large amount of wind farm going on and so forth. Now, these are some of the ones that are out in West Texas from Vestas. And one of the things that's sort of interesting is we're seeing the FlexCAN drivers being added into Zephyr. We saw that starting in 2019 for CAN bus and so forth. And embedded is an interesting space. You don't know who's using your code. So you look at these little breadcrumbs and you look at commits and you see who's working at it and so forth. And Henrik actually works for Vestas and is actually the 22nd most prolific contributor to the Zephyr kernel. However, the parts where Zephyr is actually being used are more in the sensors, actuators. They're not things that you can buy online. They're nothing visible. So it's harder to really be able to see that Zephyr is there, but Zephyr is being used there. And it is a point where we are bringing these things together in a way that we can use it as the infrastructure is refreshed and as we're going to more greening infrastructure. Power is exceptionally important, and having solutions that sip the minimal amount of power is obviously going to be key, as well as things that are reliable and can go through safety certification, because a lot of these large devices start to become used in places that are safety critical. So to give people a little bit of a feel for Zephyr, Zephyr is an open source project. We started it 5 years ago now. And over the last 5 years, it's built a very vibrant community. There's over 900 contributors to it at this point in time. So, and when we started it, it was, we knew we needed to have a solution that could be used for secure communications, as well as being used in the applications that may become safety critical. So we've been slowly and surely evolving towards getting towards a safety certification. So that's the path we've been on. And we're starting to get to the stage where some of these things will be much more visible in the year to come. Zephyr itself is cross-architecture. It's designed for where Linux is too big. Linux doesn't get smaller than about 2 meg these days for image sizes. Zephyr, can go down to 10, 20K, and depending on what you want to add, it's very modular. So you only need to add in what you want and build what you want, which makes it very suitable for embedded applications. We also have we did take another lesson from Linux, though, and in addition to the device tree, we also are using an LTS concept. For every 2 years, we come up with an LTS release, and I'll go into that a little bit more. But we are planning to be able to use this next upcoming LTS and go after some safety certifications with it. So I'll be going into that. Right when we started the project, this was our vision statement. We want to be the best in class RTOS for connected resource-constrained devices, and we want to make sure it's built to be safe and secure. Now, there are actually products in the field already running Zephyr. They've been emerging over the last couple of years, and the pace is increasing now that we have had some maturity and we've got some wider adoption. But as you can sort of see, none of these are directly energy components. So this is because a lot of where Zephyr fits is in the sensors and actuators. So it's sort of hard unless people come and tell us they're using Zephyr for us to really find that out, or we see them contributing upstream. Now, there are 7 architectures supported by Zephyr, so there's a pretty good chance that if you're using one of the modern hardware architectures, there'll be a Zephyr port out there for you to work from. We started off with the M cores for ARM. That's where we were roughly aiming, but R cores got added for real time, as well as A cores. And then we also have 32 and 64-bit on x86 and 32 and 64 on RISC-V. And like I said, just in the last year, the Spark architecture was added in because some people wanted to work from that. Now, this has meant that we have over 250 boards already in the repo. So, like I say, if there's a system that you're looking at working with for the sensors, actuators, small constrained things, there's a good chance there's a development board already in the repo that you can start looking from and evolving from for your specific application. Zephyr's architecture also has a very complete stack now. It's more than just a kernel. And it's, as I'm saying before, it's configurable and highly modular. So you only need to compile in what you need. And it creates, the static images. And so we have the cooperative and preemptive multi-threading going on. There's a lot of controls for how you want to allocate your memory and your resources. There's a lot of flexibility there. There's memory protection there, as well as a wide range of communication protocols. In particular, I'll shout out the Bluetooth low energy, because we stay current with the latest Bluetooth. Zephyr is being used by the Bluetooth SIG as a proving ground for the new specs, and so we are and as soon as they become public, you find it in the Zephyr repo. So if Bluetooth is a technology you work with, Zephyr's got a pretty good story. We're obviously looking to expand into some other technologies, Zigbee, ultra wideband, and so forth. So, as well as, obviously communication, some of our, there are solutions out there where Zephyr has been hooked in with proprietary modems and for 5G and long range communication as well. Now, how we can go after safety? Well, the development flow in an open source project, if you're effective and successful, with 900 contributors that have contributed into the project, we're seeing probably over 100 a month participating actively. And you can go look on this on our GitHub site. Just go under Insights, and you can look and catch the latest stats per week, per month, things like that. It's all, like I say, transparent and public. But that type of rate means that we're about to commit an hour, which is not exactly the speed you want to be doing something at for safety certification. So right at the start, we recognize we're going to need to figure out how to throttle the space. And so we came up with the concept of following the path of the Linux kernel and coming up with the long-term support. Now, that long-term support is what we're using as a base. So this next upcoming LTS release later this year, a subset of the features and functionality in that architecture stack you just saw is what we will be taking through the certification with the authorities for a reference app. And that's kind of how we'll be moving this all forward. Now, the LTS is a very valuable, useful thing for people in the sense that it's also important to remember that it is product focused. It does keep up to date with security. And you cannot have safety without having the security. So it is there as an option for people for products, and it's a good starting point. And we needed it in place for us to move towards doing safety. And as part of keeping an LTS up to date, you have to do maintenance fixes and maintenance updates. So you'll see that we have done several already for the project. And as security updates happen or key bugs happen, we do issue these updates. And we have committed to doing it for 2 years initially. And actually, we just finished revising that, and it'll be 2.5. So we have more of an overlap with the next LTS coming out, which is our plan for later this year. Now, that auditable code base you saw in the earlier diagram, that's going to be at the heart of what we're going to be looking at for taking through safety certification. It's going to be a subset of the LTS. You can think of it like the LTS, but it's just subsets of modules that we will take through. And there's more process applied to this. Specifically, the processes are being determined by our security and our safety committee. And they coordinate with the technical steering committee so we can make sure that the whole code base has these things consistently applied. Now, the security team has been making since the start of the project. It was established in 2016. We do have it, Zephyr, as CVE numbering authority, or CNA. You might hear that term thrown around. And we are one of the few open source projects that is listed as that in MITRE's list of CNAs. So if you wanted to go and check there, you'll find listings to our security policies and our vulnerability policies and disclosures and so forth. The other thing we've done in Zephyr for quality and for other constraints is we actually have gotten a gold badge from the Core Infrastructure Initiative's badging project. And we're one of the few open source projects that have done that. I think there's less than 10 or so. And we've had what now since about 2019. So we're doing our best to find anything we can find as the best practice and adopt it into Zephyr, because we want to make sure that the quality of the code is high and it is reliable for people. And part of that is going to be leveraging as much automation as we can find. We have weekly coverity scans going on. We're working with Parasoft right now to incorporate their MISRA scanning, because we're moving the code base over to MISRA, but more about that in a little bit. Now for safety, obviously, we're going after the MISRA C compliance into the code base. We're moving our code base over. So the next LTS will be MISRA compliant, and then we'll be keeping it MISRA compliant going forward. And the governing board determined last year we will be going after 61508 with a target of SIL 2 for a subset of, SIL 3, sorry, for a subset of the components. And this is useful for a lot of the industrial spaces, and which is hopefully of interest to the energy sector and those who are working on the robotic side. It's a good precursor for a lot of other open source standard, well, not open source, but it's the ISO standards and IEC standards are based off of 61508. And it is the first one we're going after. It's not going to be the only one we'll go after, but this is the first one we're going after as a project. And we'll be working forward from there to transform it into these market segments that are interested in it, and into the safety, where this is a good an option. So we established our safety committee in 2019, and we got very active in it last year. As I said, the 61508 is our first target standard we're going to be conforming to. And our coding practices have been documented, and there's coding guidelines available if you're curious to see them. We've done a lot of work with the TSC to agree on a set of coding guidelines for the code base, and to follow and build it up and still keep it sort of, when you've got deviations, make sure they're understood as to why and so forth. And in addition, like I say, the CI best practices badge, there's quality aspects associated in that badge. And so it's doing good things like that. Well, working through any best practice we can find to make sure it's adopting the code base is, we're trying to lay some new ground here. So we're learning from other projects as well as from, what we see as best practices. Now, the other thing, obviously, we're going to be doing is leveraging as much automation as we can get our hands on. The Coverity scans the code base weekly and, detects issues with anything that's imported in. MISRA scans from Parasoft are being incorporated, I've said. And we're also looking at various tooling in open source, because we're not the only project that's trying to go after being able to go after safety certification. And so, there's some degree of sharing of, oh, hey, I found this, can we use this? So there's things we're doing with Doxygen and other open source projects to make the documentation in the project available and suitable to be used in the safety certification. Because we have to build ourselves up here, because there isn't a lot of precedent for open source projects going through these things. And we need to go there because this is where all the innovation is. 90% of the, based on various surveys by various, source code analysis companies and things like that, about 90% of the products they look at have open source in them, and of those products, about 70% of the code is open source. So open source is pretty prevalent. Most people take it as a starting point and then build up, the value add on top of it. From the Zephyr, and what we're trying to do is, we sort of recognize right from the start we need to have a very high quality solution. It's not an add-on; it's actually part of the processes. We've got multiple reviewers per code, and we need to make and whenever we find a quality process, it was what we were using is documented. You can find some of them in the CI best practices, but there's more than that we're doing in terms of the group. And when there's an active process group that's looking at refining our processes ongoing. So this is a journey. Now, what we're going to be doing for our first certification is only looking at a subset. So we're looking at some of the APIs. The things in blue we're going to be taking and putting into our first certification, because we'll be adding components and communication things bit by bit, but we recognize we need to start with more of a kernel and then build our way out so that the various, the file systems, the devices, the logging, and so forth are there. The various kernel services, the scheduler, power management, things that you sort of expect in a basic kernel are going to be part of that first certification so that people can build on it. What we're looking here is to give people a foundation and let them, and we're focusing on what hopefully everyone will use in common. And then if people want to use certain components, they can take and do an additional and amend on from the work we've done. Now the code for this is going to be available to everyone. The Zephyr code is available to everyone, and we're being very transparent about it. But what we're trying to do is work through this process, make sure we know how to do it, and go from there. Right now we're working on the 2.5 release, and we are doing a lot of work hooking up the code base for the traceability between the requirements and what's actually in the code and what's tested. So doing that V model linkage is something we're sort of reverse engineering onto the code base. And as we get ourselves set up for those components you're seeing, as we sort of go the other components, we'll be basically extending this beyond there. We are looking at tooling, what tooling we're going to be using for going after the certification. There's a variety of proprietary tools out there already that are safety certified and can be used. We're looking at options in this space, and we're also going to actually engage, well, we're in negotiations to have work with a specific certification authority to see us through the initial assessment and then do the certification with us later. Obviously we're, regression and testing regression and getting that CI infrastructure is in place. So this is what we're doing right now in our current release. And our next release is going to be working towards, getting the compliance and so forth. So these are the sorts of things that we're sort of looking at as we work our way forward. And then there'll be a variety of collateral from the safety auditors are expecting. There'll be a traceability report, the compliance matrices, the safety analysis, the verification and validation test reports. And the safety manual. These are all things that the standard expects, and we're going to need to be producing as part of a project. Now, those things are not necessarily going to be available to everyone. We're going to be, a large part of the work is obviously the code, and everything else will be kept public, but we'll probably be making the subset of the artifacts available to our various members. Because it's not cheap. It is not cheap to go through safety certification at all. And the extra resources and testing and so forth. We need to help the members that are funding this, get a return on investment. So some of these reports that we're producing as part of the safety certification will be available only to the members. been participating. Now, as we go through this whole thing, we are very much keeping in mind that there's a variety of places that Zephyr can be showing up and can be used, be it from a single core MCU, AMP, SMP architectures with different cores, through hypervisors, through mesh networking. All of these are configurations we could be seeing Zephyr used in potentially in a safety context. And it's going to have security is going to be required. We're probably going to be starting at the small end and building more sophisticated things up over time. But the key is we're going to be trying to start and then give a framework that people can extend when they need to for their specific cases. So to summarize, in 2021, our path to towards getting safety is we are working towards the sharing of the best practices with other open source projects, in particular Zen, Acorn, Elisa for Linux, and others that are trying to go after safety certification. The communities are actually talking to each other. They all have safety committees, and so figuring out what works and what doesn't work, what makes sense, working with the standards. The open source communities in general have a problem in that the safety standards are available, only available behind a high cost pay firewall. And so the general open source developer doesn't have access. This is certainly a challenge when going after safety standards to help people understand why. Because overall, I don't know an open source developer that doesn't care about quality of their code in some sense. But to understand the argumentation and why certain things have to be done in certain ways, and the system approach to look at it all, these are elements that when you go through the standards it makes sense, but if you are just looking in from the outside it doesn't necessarily. So this is a challenge for all the open source communities, and we're all sort of looking creatively at ways of working our way around this elephant a bit. So you might be seeing some of the things emerging from that. In Zephyr itself, Parasoft joined the project to help with the MISRA and safety scans. And so we're deploying their tooling right now in Zephyr into the CI loop infrastructure. And we are actually contracting with the safety certification authorities. It's in the contracts or negotiations with a couple right now, and we'll determine based on the results of what the safety committee feels comfortable working with, which one we'll be going after. So LTS2 that's coming out later this year is going to be our basis for that auditable code base I've been talking about. But the transformations in the code base are happening now. It's not like we're going to transform it then. We're transforming the code now, and then we'll be doing we'll be documenting the analysis after the LTS comes out. So that's Zephyr's path as we're going towards safety certification in the next year. If you've got any questions about Zephyr, please feel free to reach out to me or zephyrproject.org to learn more about the project, and click on info to learn more if you've got a question. And happy to share any questions you've got in the chat now. Thank you very much. Hey, so does anyone have any questions? It's rather unfortunate that there was lovely other Zephyr talk right at the same time as this one is. So I'd encourage you guys to check out that talk about the Libra Solar, which is another Zephyr application I've just learned about from coming to this conference. So I think the comment of we're seeing Zephyr showing up in many places is that we didn't all expect, pretty much spot on still. Anyhow, thank you very much for coming and listening, and feel free to reach out to me if you've got any further questions about Zephyr. Thank you. Just looking at the chat, okay. And I think I will say adieu and enjoy the rest of this conference.